So this is 2025 paper 1 question 9, and we're basically given a function for fuel consumption and in terms of speed, and we're told to show that there's no difference between the fuel consumption at 60 compared to 110. So you can basically just sub in f of 60, sub in f of 110, and show that they're the same. And when you plug in the numbers, you get 470 liters per 10,000 kilometers for both, so that means that f of 60 is equal to f of 110, as they asked. In part 2, we're basically just asked to differentiate this function. So if we do df over dc, well, we differentiate 0.05 c squared, bring the power down to the front. So 2 times 0.05 will give us 0.1. C, reduce the power by 1, will be c to the power of 1. Then minus 8.5. And the power here is just 1. So 1 times 8.5 is just 8.5. Reduce the power by 1, you'll get c to the power of 0, which is just 1. And then the derivative of a constant is just 0. So this is our answer. And the units don't really matter. They don't really care about them. But if you were to, and the reason is because they're very difficult, but if you did want to know the units, which is, I suppose, might be good for your own understanding, well, we have units of fuel consumption over units of speed. So basically, the units of fuel consumption is liters per 10,000 kilometers. And that's divided by the units of speed, which is kilometers per hour. Because we have fuel consumption over speed, df over dc, so it's very difficult, so that's why they don't really use units, and I'm not really going to mention the units for the rest of this question for that reason. In part 3, we're told what the speed is in terms of time, and we're asked to use that to figure out what df dc is when t is equal to 7. Well, df over dc, we can plug in values for c, but we don't know what is c when t is equal to 7. Well, we can figure that out from here. So when t is equal to 7, c will be 78 plus 9 ln of 49, because that's 7 squared, and we can put that into your calculator, and you'll get roughly 113.03. So that's what c is when t is 7, and then we can just sub that into here. So now df dc when t is equal to 7, or in other words, when c is equal to 113.03, well, then we just replace that c with 113.03, and then figure out what that is equal to. So that gives us 2.803, and then it says to one decimal place, so let's say 2.8, and again, they don't really care about the units because they're very long. So then we're asked to find dc over dt, so you just have to differentiate this function, which is quite easy. So remember, c is equal to 78 plus, and now to make this a bit easier, you could differentiate this, or you could use the laws of logs to bring this 2 down to the front here, because you can do that with logarithms. So 2 times 9 will give us 18 ln t. And that just makes it a bit easier to differentiate. So now we'll have dc over dt will be equal to derivative of a constant to 0. So then we're going to have 18, and the derivative of ln t is just 1 over t. So we're just going to have 18 over t as required. So then we're asked to use these answers to find the rate of the change of the car's fuel consumption, f, with respect to time. So basically, we need to find df over dt. So we know dc over dt, and we also know df over dc. So if we have, so this is what we want, and we have dc over dt and df over dc. So you can kind of think about it. If we were to hypothetically multiply these together, the dc's would cancel and we get df over dt. That's technically not how derivatives work, but for the sake of leaving cert maths, it's fine to do it like this. So dc over dt times df over dc, that will give us exactly df over dt. So now dc over dt is 18 over t. So we'll have 18 over t multiplied by, and then df over dc is going to be 0.1c minus 8.5. So multiplied by this, and that's equal to df over dt. Now they asked at the instant when t is equal to 7 minutes. So remember when t was equal to 7, we found that c was 113.03. So that's everything we need to know to sub it in. So df over dt when t is equal to 7 is equal to, so we're going to have 18 over t, and t is 7, multiplied by 0.1, and then remember c was equal to 113.03 when t was equal to 7. So you have 113.03 minus 8.5, and that's a bracket, and then we can just put that into your calculator. And when you do that to one decimal place, it doesn't really matter, they didn't specify, but we'll do to one decimal place, we'll get 7.2, and then the horrible units of liters per 10,000 kilometers per minute. And that is our answer. So for the next part, we're given a piecewise function and we're asked to fill in this table. So basically, when t is between 0 and 4 and including 4, we use this function, and then otherwise we use this function. So we have to fill in 1 and 3. So for that, we sub in 1 and 3 to this first function, and we get these answers, which I filled into the table. And then for 5 and 6, we use this function, because that's for when t is between 4 and 8, but not including 4. And we get these answers. And they're also rounded to 1 decimal place. Then we're asked to draw the graph. Well, I guess suppose sketch it. So it doesn't have to be super accurate, but I'll show how you do it. So 0, 0 is a point, then we have 1, and then we have 3.9. So 3.9 is going to be like around 4/5 of the way up this box, because this box is 5. So 4/5 of 5. It gives us roughly 4, so about there-ish. Then 2 and 9.8, that's just under 10. And then we have 3 and 18.6. So again, that's going to be just under 20, about here. And then we have 4 and 31.6. So it's about 32, roughly. So it's about halfway, just under halfway there. 5 is 46.6, so that's just over 45, just under halfway again here. For 7, we have 70.6, so it's going to be barely above 70, but not really noticeable. And then we have 79.6 for 8 seconds, so 79.6 is going to be just there. Sorry, I skipped a point there. 6 should be just under 60, roughly there, and 5 is 46.6. That's my apologies. That should be roughly here. And then you just want to try to connect those smoothly. I'm not going to be able to do it too well here, but you should be able to do it on paper a bit better. So again, just drawing like a smooth curve to go through these. Something looking roughly like that. And that's what they had in the marking scheme, so it's pretty similar. Finally, we're asked to use integration to find the average speed. I find this to be a bit confusing because of the units. We have like t is in seconds here, but then the velocity is in kilometers per hour. But I suppose an easy way to visualize this is that if it's the average value, it's just going to be like the height anyway. So it's just going to be the kilometers per hour. We don't really have to worry about the other stuff. And that makes sense when we look at the formula, if you try to understand it. So the average value is equal to 1 over b minus a times the integral between 0 or between a and b of, well, in this case it'll be v of t dt. And the reason for that is this will give us the area under the curve, right? So this will give us the entire area under the curve. Say it's all of this stuff. Let me just get rid of this graph quickly. So if we get the area under the curve, all of this, and then if we divide this, the 1 over b minus a, that's basically just these are the t values, right? This is the x-axis. So these are the two values between which we're integrating. In this case, it'll be, sorry, we're doing this between 4 and 8. So I shouldn't have shaded in the whole thing. It's just the area under this part. So we're going to do this integral between 4 and 8. So a will be 4 and b will be 8. So if we divide by that value, it's like dividing by the width. So you're kind of finding, if you have area divided by width, that gives you the height of the rectangle. So it's just in kilometers per hour. So this is in kilometers per hour multiplied by seconds. But then this is 1 over seconds. So that'll just give us an answer in kilometers per hour. Maybe that's too confusing, but I think it's good to kind of connect everything together. So we're doing this between 4 and 8. So we're going to have 1 over 8 minus 4 are the two limits. Then the integral between 4 and 8. And then here we're using the second one because it's between 4 and 8. So we're going to have minus t squared plus 24t minus 48.4 dt. And then what we're going to have is we're going to have a quarter. And then when we integrate this, what we're going to get is we'll get minus t cubed over 3. So we're adding 1 to the power and dividing by that power. And then if we add 1 to the power here, we'll have 24t squared divided by 2. We'll have minus 48.4 t to the power of 1 divided by 1. Doesn't really matter. That's between 8 and 4. To save time here, 24 over 2 is just 12. So I'm just going to replace that here. And then we're going to have a quarter multiplied by, so we'll have minus 8 cubed over 3. Plus 12 times 8 squared, minus 48.4 times 8. And then we're going to have this thing, okay, And we're going to have minus, and then we're going to sub in everything with a 4. So we're going to have minus 4 cubed over 3. So it's important to be careful with the signs here. So I'm going to sub everything in as it is with 4, but then I have a minus on the outside because we subtract the top one from the bottom one. Then we'll have plus 12 times 4 squared minus 48.4 times 4. And then close that bracket. Okay, so what we're going to get is a quarter, and then... So I won't bore you with just kind of writing these out, but I will draw your attention to this minus and this minus made a plus here, and then the minus and this plus made a minus here, and this minus and this minus made a plus down here. So just to be careful with the signs when you're doing those, and then you can just add all those together. And that'll give you, we'll have a quarter, and then this stuff simplifies to 3496 over 15. And then we just divide that by 4, and that'll give you 874 over 15. And then they want it in kilometers per hour correct to 1 decimal place. So we're going to get 58.2666 repeating. So correct to 1 decimal place, that'll be 58.3. Answer, as I said, is in kilometers per hour. And we're done.